According to the JetBrains Developer Survey in 2020, about 55% of Python developers are asked to conduct analysis tasks and work with data science tools. This is typically something like Jupyter or Pandas or NumPy. As you might expect, one of our top user requests has been making it easier to use MongoDB with these tools. So today, I'm going to talk about the new library we are releasing for 5.0, PyMongo Arrow. To start us off, this is a conceptual NumPy array. Once you create this array in NumPy, what actually happens behind the scenes is that it creates a vanilla C array. The C array is then wrapped in a Python object and given back to the Python interpreter. From there, developers can pretty easily slice and dice the data. Of course, the format above looks nothing like the documents we have in MongoDB. Getting from a MongoDB query that might return many thousands of documents to a NumPy array format or a Pandas data frame is somewhat complicated. You can use the plain Python driver for MongoDB to get your data into the Python data ecosystem. That's always been possible, but there's a fair amount of extra work involved. It's custom code to convert the data into Python lists, then convert it into something like Pandas data frames or NumPy arrays, as you can see here. And as someone who has attempted to do this myself, it's pretty unclear how to do this well. It's not optimal in terms of memory usage or performance in terms of speed. Pandas itself doesn't have great low-level APIs as abstraction layers, and I spend a lot of my time reading the documentation. So I'd like to introduce you to part of our solution, Apache Arrow. This is a great open source project that answers a lot of the questions and issues that we find as developers trying to work with data science tools. What's great about Apache Arrow is that it eliminates waste of doing the custom code to massage your data in memory. It addresses needs to serialize the information and send it over the wire to workers in a compute cluster. And it stores the data in a file format in which it can be easily read for quick analysis, like a memory mapped file or something like Parquet. This is our model of the technology landscape, with Arrow being a foundational technology sitting very close to the Python interpreter. It's not a Python-specific technology, though. It's a standard with a Python API and library. It has implementations in other programming languages should you wish to use those. So here is the PyMongo Arrow API that we built. Very simple, very powerful. Developers define their schema as a map, then issue the query, find pandas all, which you give the collection on which to run, the query itself, and then the schema. At the high level, this is what happens. You'll read everything from bson to Arrow. Arrow's Python connector has a lot of utilities, which allows us to convert to Pandas format or NumPy format. A little closer inspection of how this works is, at initialization, PyMongo Arrow will look at the schema defined by the user. And then as it iterates over the fields in your MongoDB documents, we build an Arrow table, giving you a new data set in Arrow table format that matches the query. If there are missing values, these become nulls. Pandas has a lot of great utilities to replace nulls with completed values, so we allow developers to do this elsewhere. Extra fields in your data aren't ignored. Once we process the schema, only those fields get returned from MongoDB, so it's not a complete dump of your data. Thus, we minimize the network traffic returned to the client. Arrow also has a variety of formats and integrations they've already built, and it's trivial for you to use these as well. There's also some other benefits to using the PyMongo Arrow library. It's super easy to install, one line of code only. We don't envision that the API will ever change. All the changes we plan to make from here on out are additive. We also added some knobs so you can specify missing values as maps or things like that, and we'll add more to come. PyMongo Arrow also already works with aggregates. They're a method for both NumPy and Pandas, aggregate Pandas all and aggregate NumPy all. We're really excited about this new library for Python developers, and we really would love you to try it. So I've linked the documentation and the source code here.